So we already figured out that we could express our compound interest growth here sort of recursively in the form PM equals PM minus 1 times 1.0025, or in other words, the new month is the previous month times 1.0025. So let's see if we can take that relationship and come up with an explicit form for it. Now, if you've already done growth models, you might know where this is going, but let's go ahead and walk through the steps. So, P0 was the initial amount that we start with. After 1 month, we'd have P0 times 1.0025. After 2 months, I'd have P1 times 1.0025. But where did P1 come from? P1 came from here, and so I'm going to have P0 times 1.0025 times another 1.0025. Or in other words, I could simplify that down to P0 times 1.0025 squared. After 3 months, that would be the previous month times 1.0025. But where did P2 come from? P2 was all of this thing, so this would be P0 times 1.0025 squared, that's P2, times another 1.0025, or in other words, P0 times 1.0025 cubed. And you might be seeing the pattern here, that after any number of months, the amount that I'm going to have will be P0 times 1.0025 to the m power, where m is the number of months that have passed. So let's see if we can generalize that now to an general form equation. Now, we really want our equation to involve the initial amount P, R, which was the interest rate, K, which is going to represent the number of compounds in a year. So in this case, we were compounding monthly, and so K was 12. There was 12 compounds in a month. And we want N, which is going to be the number of years, because working with months is just sort of a little bit more confusing in most cases. So let's see if we can break down what's going on here. So we want to rewrite this equation in terms of years, in terms of n. So we're going to have our initial amount, P0, and then where did this 1.0025 come from? So if we skip back for a second, remember that the 1.0025 was coming from the interest rate of 3% divided by 12 months to figure out the interest per month, plus 1, because we were adding on the original amount. So if we go with that idea, then this is going to be 1 plus, this was the interest rate divided by the number of compounding periods in the year. And so this is going to give me the interest per compounding period. So now, we need to figure out how to take the number of years and create the number of months. Well, let's think. If I had, let's say, 4 years, how many months is that? It would be 4 times 12 is 48 months. And so if I wanted to know my balance after 4 years, I would put in 48 here for the months. So where did this come from? This was the number of years, n, times 12, the number of compounding periods in a year. And so the n times k here ends up giving me the total number of compounding periods. No matter how you think about it, here is our final equation then. This is our equation for compound interest.